Hi, everyone. How are you doing? Cool. Good. So my first question before I get started, how many of you have spent like more than a day playing with React or used React professionally? Cool, so like half. What about Redux? Cool, so I will call back to that occasionally, but not all the time then, because not all of you are experienced with it. So before I tell you who I am, I like to start with an XKCD because XKCD is fantastic. And really just like what I'm trying to say here is that everything that we're going to cover in this talk is actually very old. They've been repopularized recently, largely due to React and Redux, but this XKCD has been around for 5 years. Haskell and Lisp have been around for like 40, 50 years. So none of this is new, and this is a great old comic. So my name is Matthew Gerstman. Like we said before, I am a software engineer at Dropbox. As an obligatory plug, we are looking for engineering managers right now. So if you're one of those, talk to me. You can follow me on Twitter at Matthew Gerstman. When you do that, I feel good about myself. Please follow me on Twitter. And if you want to see a link to these slides, they are at bit.ly/FP fundamentals. And seriously, please follow me on Twitter. I'll feel really good after the talk. So what are we going to talk about today? We're going to talk about functional programming, and we're going to talk about imperative versus declarative styles. And you might have heard about these things, especially declarative and imperative, in kind of like a buzzwordy sense. And today we're actually going to get into what those things mean. So what are we not going to talk about today? So if you've heard of FP before, you might have heard of monads or lambda calculus or functors or other scary functional jargon. If you think those things are important, then this talk is not for you. We're going to avoid all of that because we want to make your code better. So I like this one as well. Functional programming combines the flexibility and power of abstract mathematics with the intuitive clarity of abstract mathematics. So historically, FP just got a bad rep, and there's no wonder why. If you look at the Wikipedia page for lambda calculus, I don't know what this means. I don't know if any of you know what this means, but it's not important. We're going to move on. So Tay says this is absurd. You're going to see a lot of her tonight, and I thoroughly agree. So we're going to take a step back now. I believe in two things. One, that you should use the best tool for the job. And two, much like this ice cream emoji that you can't all see, moderation is key. So we're going to shake it off. I promised more Taylor. And we're going to move on. So what's the point? We want to make our code more readable. We want to make our code easier to reason about. We want to make our code easier to test. And we want to make our users happier. In fact, I like to say that we're optimizing for happiness because we're optimizing for developer happiness and user happiness. Like those are the things that we're going for here. So when is functional programming most useful? So functional programming is most useful when we're doing one-to-one data transformations. So in a React Redux app, you'll commonly have Redux or whatever other form of application you're using. If it's like Backbone or Angular, you have some form of data store in the back, and then you have some type of view layer in the front. And you want to have this one-to-one data transformation so that you can store it however it makes sense in the database, or front-end database, I should say, and then push it out to the view layer in the way that makes the most sense for the view. So these are some TypeScript types. You don't need to be too familiar with TypeScript. But basically, I'm storing in my data store a map of users keyed by ID, which we would commonly want to store them that way for constant lookup. And then in the actual component, I want to take a list of users, which is just an array of users, so I can spit them out to my users and show them like a picture or whatever it is. So in the middle, we'll have a function that will take the first data type and convert it to the second data type. And that's what I mean by a one-to-one data transformation. So let's take another step back and say, what is functional programming? Functional programming, often abbreviated FP, is the process of building software by composing pure functions. Now, the next obvious question is, what is a pure function? A pure function is a function which, given the same inputs, always has the same outputs and has absolutely no side effects. So 2 + 2 is always 4, 3 × 3 is always 9, etc. And I'm going to give you some examples of side effects so you know what I mean. Now, what I want to clarify is that side effects are not inherently bad in your code. Some of these things are things that we need to do. The best example, which I'll get to, is like hitting a server. Like that's a side effect that we have to do, but it just means that your function isn't pure and you can't rely on it to always have the same input-output, which gets important as we move on to some of the other functional programming concepts. So the first example of a side effect is mutation. In this case, I have pop, which you might have seen before, which takes the first element off of an array and it returns it. And the thing is, down here, we've modified the original array. So if you keep calling it on the original array, it's a different output every time for the same input, and that way we can't guarantee the same input and output, so it's not a pure function. Another example is shared state. So in this case, I have this global I variable, and I'm incrementing and decrementing it from these two functions. And depending on the order I call these functions in, a different value could be spit out. The other thing is you could change I to a string, and then I actually figured this out. String plus plus is not a number. So that's, if you're wondering what string plus plus is, now you know. But either way, shared state means not a pure function. And then lastly, like I mentioned before, async code. In this case, I'm just using a set timeout, which just like you mentioned before, the loop could be full. And we don't actually know when this is going to fire, so we don't know what the value of I is going to be at any given point. And if we're hitting a server, then we definitely don't know when the data is going to come back or if it's going to come back. So Taylor wants to be excluded from this narrative. I'm with Taylor, so we're going to move on. So let's look at an example. So this first function is called clone, and it takes an object, and it uses the newer ES6 syntax. All this does is it copies over the object. How many of you are familiar with ES6 syntax? Cool. OK, that's almost everyone. So yeah, this just copies over an object. And I have a function called killParents, which takes a wizard, and you can guess what wizard it's going to take. So it marks the wizard's parents as dead, and it returns the wizard. So it's mutating the wizard. This next one, we're adding a scar. Yes, this is Harry Potter. Now it says Harry Potter. And we're going to add a scar to Harry Potter. And if I call these functions in order, what you intuitively expect from reading this code without looking at the functions is Harry Potter, Harry Potter, Harry Potter with dead parents, Harry Potter with dead parents, and a scar. But is that what's going to come out of here? No, that's not what's going to come out of here. So what actually comes out is Harry Potter, and a scar with dead parents twice, and then undefined, because first of all, fun fact, I introduced a bug here. This didn't return anything. And second of all, B and C were both operating on the same reference, so we killed his parents on the same Potter twice. So that's no good. Cool. So now we're going to move on to declarative versus imperative, and I could not find a Taylor Swift GIF or a Harry Potter GIF to fit this, so I present you with Zoidberg sucking on a turkey. It looks delicious. I don't know what episode this is from. If you know what episode this is from, you get bonus points. You get 20,000 points. You get an N64. You're not going to get enough points for that, though, so don't worry about it. So declarative code describes what it does. And if you're familiar with React or something else that uses JSX, we can see here that this is a function which takes a counter, and it just spits out a span that is that counter at any given point in time. And we can always guarantee that when this function is called, it's going to spit out a span with the current counter. Imperative code describes how it does it. So in this case, we have to when we get the counter, we take the counter value, and then we have to get the counter from the DOM, update the inner HTML, and we're doing all these steps. Now, there's something kind of obvious here that people always wonder. It's like, well, how do you get from A to B? And it's that declarative code will always end up compiling down to or being processed by something imperative. So two very old functional languages called Haskell or Lisp, which are theoretically both declarative, or SQL, which is theoretically declarative. Eventually, they're compiled down to imperative code, even if that just means it's imperative code when it's running an assembly language on your processor. So there's always an engine in between, but the way we look at it is we say we want to make our code as declarative and as easy to reason about as possible, and let the imperative engine under the hood, which is very good at DOM mutations, go do its thing. So that's how we view that. So I have a couple examples here. So this first one, because I'm at Dropbox and we like to get files, we take a list of files and we want to turn it into a map. So the reverse of what I did on one of the first slides, we're going to take an array of something and key it by ID on this map. And this works. There's nothing really wrong with it. I think it's 8 lines of code. Sorry? Someone say something? OK, sorry. So anyway, it's like 8 lines of code. It works. But this is like kind of a lot in the middle of your code. And funnily enough, there is a super stupid performant way to optimize loops where you start at -1 and do ++i is less than the thing because it combines some checks. Don't ever write your code that way. Please don't ever write your code that way. But Lodash actually does write its code that way. And that works because the imperative engine under the hood is hyper-optimized for runtime performance. And then your code can be declarative and you don't worry about it. So instead of doing this, we're just going to call out to lodash.keyby. And I should mention, you don't need to be using Lodash. You could use underscore, you could use Ramda, you could use immutable. As long as you're not using mootools, if you get that reference, like just use whatever you want. But we use Lodash at Dropbox, so I use it for my examples. Another good example is get file names. So in this case, we have a list of files, and we want to grab the name property off of each of them, well, this is just a map. A map says, loop over this thing and transform it in this way and give me a new array. Lodash has a shorthand that if you just want a string property off the object, you just call name. Cool. So that was a lot of information for all of you in a short period of time. I know I talk fast, so for my own amusement, I'm going to move on to something completely non-technical for a moment. I promise Taylor Swift. So Red, in my opinion, is Taylor Swift's most important album. This is when she transitioned from a country star to the modern Madonna she is today. No one finds this as funny as I do. But the track list is fantastic. Seriously, just go listen to it. Do yourself a favor. We're getting back to FP. Now you guys can thank you. That was from me. Harry with his wand, it's like getting a wand. So we're going to talk about pairs of concepts now. The first one is called separation, which is that if you try to perform effects and logic at the same time, you may create hidden side effects, which cause bugs in the logic. You want to keep functions small, and you want to do one thing at a time, and you want to do it well. And that pairs nicely with this other concept called composition, which is that you should plan for composition. You should write functions whose outputs will naturally work as inputs to many other functions. You want to keep functions' signatures as simple as possible. So let's look at some examples. So I have these like filey method functions. The first one's called sort files by name, and it takes a list of files, and then it returns them sorted by name. It just calls out to Lodash. The next one is get PDF files, which uses filter. Filter is a functional programming concept, which is now built into JavaScript that says filter in. So if the file has this property extension and it's PDF, then we're going to keep it. Otherwise, we're going to get rid of it. And then this one gets the file names from each of them. And these are all really nice because you can wrap these together because they all take one input and produce one output that's very, very predictable. And that's what's nice about not having side effects. So Lodash actually has a utility that takes advantage of this called flow. And the way flow works is it's very much like a bash pipe or the pipe operator that we might get in JavaScript. It's currently in stage 1, I think, in TC39 land. But anyway, so I pass get PDF files to it, get file names to it, and then it's actually already an array of strings, so I just give it lodash.sortBy, and it produces a new super duper function called get sorted PDF file names that will take whatever its arguments are, pass it to the first function, and then this function's output will go to this function, and then this function's output will go to this function. And we've now combined these little functions that are very general into something bigger and more complex. And just to kind of illustrate what's going on here, it's the exact same thing as doing this, where we call get PDF files, we call get file names, and then we sort them. But so Lodash flow has some ever so minor performance optimizations inside of it. It stores metadata on your functions such that if you flow multiple things together or use like multiple wrapper functions together, it will use the original functions and be smart about that. But the second one might be more readable. I'd tell you to figure out what's best for your team. Really, this is Holy Wars territory, so just do whatever you think is best for you. Next two concepts, immutability. And this one actually really shows where it came from. The true constant is change. Mutation hides change. Hidden change manifests chaos. Therefore, the wise embrace history. I got this from an article called The Tao of Immutability, which I think is the funniest title. Next one is memoization, which you might have done before, which is an optimization technique, which if you have a pure function and you know that given a set of inputs, it will have the exact same output, we can just cache the input and then return the same output so we don't have to do an expensive computation again. And when things are immutable, those two things combine well. So I have another function that takes a wizard. I'm getting even darker now. We're going to kill some siblings. And please ignore any glaring bugs. I needed this to all fit in one slide. So we copy over the previous wizard. So we're creating a brand new object. And we're decrementing the number of siblings they have. So in the first book, Ron Weasley has 5 brothers and 1 sister. And in the last book, his brother Fred dies, and it's very sad. And if you look right here, when I call kill sibling, I'll get into the memoization part in a second, it produces a new object, Ron after Fred dies. And if we do a check to see if these are the same, it returns false, because his brother died. He's a different person now. But also, because the two objects are different and it's immutable, we can just know that anything within the object changed, and now we have a brand new object, so we have to re-render. And this is actually what React and Redux take advantage of, is they just say, hey, has anything changed? We're not going to bother recursing into the object and figure out what's changed there, because we don't actually know that much about the object, but we know how to re-render a tree, so let's do that because it's cheap. And that's what those libraries do. Now, when we memoize this, we guarantee that if we give it the same object every time, it's going to spit out the exact same reference. So if I pass it Ron to the memoized version of this function, it's going to return true because it's going to cache itself on the reference to the original object, and now it's always going to return the same output, which means that we can rely on it and know that if we want to like render down the line if something's changed, that we're not going to render unnecessarily. And then just as a caveat here, if we call the original function kill sibling with the original object and it's not memoized, I call this one Ron after movie Fred dies because the movies are not as good, and we're going to get to that. They're different objects. So just be mindful of that when you're calling a function that copies over an object, it's always going to return a new object unless you cache it in some way, shape, or form. And I promise this is the last time I do something for my own amusement. Ron Weasley is criminally underrated in pop culture because they ruined him in the movies, and he is such a strong character in the books. He's the local, he knows everything about the wizarding world. They gave all of his good lines to Hermione, and anyway, I can go on for like 10 minutes about this, but I'll do more technical stuff because that's what you came here for. Hermione's back, she's also great, but she's just not underrated. Everyone knows she's awesome. So she checked out this book a few weeks ago. We're gonna talk about higher order functions. So, how many of you are familiar with higher order components? You heard that phrase before? Okay, so one person. Higher order components are popular in React, and this is where they come from. It's an older principle called higher order functions, which just says it's a function that either takes a function as one of its arguments, returns a function as its output, or both. It can do one, two, or both. Either one or both. Anyway, first example is a callback, which we've talked about tonight already, so I won't spend too much time on. In this case, we have the fetch API, and its then function takes a callback, and we fire it when it's done hitting the API, and that's then is a higher order function. Another example is a closure, which you might have seen before. So in this case, I have this function called counterGenerator, and it returns a function that's bound to this I. Now, interestingly, counterGenerator is kind of a pure function because it always returns a brand new function, whereas counter is not because it's going to keep incrementing internally. So it's kind of an interesting nuance there. So the last one is a function that takes a function and returns a function. And I actually don't even have to write new code because I already showed some of these to you. So Lodash.memoize is a higher order function. It both takes a function and then returns a memoized function. Lodash.flow takes multiple functions and then returns a big function. I did one more just to show you something, just to say I wrote code for this slide. So debounce is a popular mechanism for so what debounce does is it prevents a function from being fired until you stop calling it for a certain amount of time. So this is really useful for like scroll handlers, because if you want to do something after the user is done scrolling, or if you want to like hit a server after the user is done typing, the function won't fire until the user stopped doing something for, in this case, 100 milliseconds. So I call cast spell debounce 3 times, and it only logs Expelliarmus once. Cool. Last section, the criminally underrated Ronald Weasley. We're going to talk about currying and partial application. So currying is a technique that transforms a function into a new function that can take any number of its arguments, or it'll just return a function that's waiting for more arguments. And I'll show you an example so this makes a little more sense. So in this case, I have a sum function that takes A, B, and C, and I'm going to pass it to Lodash.curry. So now I have this curried sum function. And in this first example, I pass it 1, 2, 3, and that returns 6 because it got all of its arguments. But in the second example, I only pass it 2 and 3, and now we have a new function that's waiting on the third parameter. And we can even do this one argument at a time, or we can do one argument and then 2, or then 1, 2, 3, and we'll get the right output from it. And there's a lot of libraries, especially Redux, that take advantage of this idea under the hood, but I won't go too much more into it. Oh, there's another one. Anyway, partial application. Partial application refers to the process of fixing a number of arguments to a function, which produces a function of smaller arity. Now, I promise no scary functional jargon, but arity is a relatively simple term. It just means the number of arguments a function takes. So now you learned a new vocab word. Arity is the number of arguments a function takes. Sweet.
Good band name.
Sorry?
Good band name.
Yeah, Arity. If you want to steal that for a band name, I'm not going to use it. I played guitar in high school. I was terrible at it. Anyway, so I have this learn spell function. We're not going to kill anyone for the rest of this talk. And we're going to copy over a wizard, and we're going to copy over all the spells the wizard knows, and then we're going to append a new spell to the list of spells the wizard knows. And I'm going to use lodash.partial to apply the first parameter, expelliarmus, or expecto patronum, to create two new functions called learn expelliarmus and learn expecto patronum. So now I've taken this one generalizable function and made it two more specific functions. And I'll call this on Harry, and Harry will learn expelliarmus, and then he'll learn expecto patronum, and those are the order those things happen in the books, and then I get to go home happy. But you've actually seen this before tonight. So remember all these examples I showed you? These are all examples of partial application. It's just not using a fancy term, partial application. We have a function called sort files by name, and we're binding name to lodash.sortBy. The same thing for get PDF files. We're binding extension PDF to filter, and the same thing for map. So you probably have done this before in your code. You just didn't realize it was called partial application. And again, sorry, right-clicked. And again, Lodash has a method for doing this. You can use either partial or partial right, and it will bind parameters either from the left or the right. And again, it has these like micro performance optimizations that if you like partially apply something 6 times, it will take care of a bunch of things under the hood for you. But do what's best for your team. If you're on a team of like 3 and you think this is fun, go write code the second way. If you're on a team of 50 and you're going to have to teach all of them how to write code like this, maybe it's not what's best for you. I'm not here to tell you what to do. So I want to take a couple steps back to the beginning of this talk and remember what we're here for. We are optimizing for user and developer happiness. And we do that by making our code more readable. We make it easier to reason about and easier to test. And our users are happy and we're happier. We're not trying to play code golf. We're not trying to reduce the number of lines of code. We're not trying to make it as terse as possible. We're just trying to make our code better and cleaner. So some other resources that I like to point out. There's a great book called Functional JS that's on GitHub. It's totally free. You can read the whole thing cover to cover. And it's very similar to this talk, except it goes much more in depth because it's a book and I spoke for 20 minutes, so I couldn't cover a book in this time span. There is a talk by, I forget his name actually. There's a talk called Hey underscore you're doing it wrong. That's from about 5 years ago that talks about functional programming and how underscore wasn't quite there. And it was really kind of pro-Lodash at the time, which back then was a debate. And then John David Dalton, who's the creator of Lodash, gave a talk about all the crazy imperative hacks it does under the hood. So that way it can be super duper performant while you're writing declarative code. So with that, does anyone have any questions? Thank you. That's not a question, that's just moving your hands.
I got a question.
Sure.
Yeah, so going back to currying, you can go, if it's just waiting to evaluate if you don't pass in whatever number of parameters that are left, like how do you keep track of to see, or is it going to evaluate up to that last parameter and then you can pass in more?
It doesn't evaluate up to that parameter. It's basically partially applying it. Is what it's doing. It's applying one parameter at a time, and then it's not going to do any logic until it gets to the very last parameter. So you're just creating a new function each time you pass it a parameter that already knows about a certain number of things. So currying could be viewed just like I showed before. Instead of using like partial application, doing it this way, you could view currying as like a more advanced version of that. It can take any number of parameters. It's a really good question.
But it hurts readability, you might say, like in a large team. Like, is there a con? Like that, is there an instance where that's a really good thing to sort of take advantage of? Like,
yeah,
is that something you do on a daily basis at work?
No, it's not something I write on a daily basis at work. I delve into the internals of Redux a lot, and Redux heavily takes advantage of currying and has a lot of functions, returning functions, returning functions, returning functions. Yes, that's the right number. It's a lot to handle. So it's less something that I need to write and more something that I need to understand when I'm delving into someone else's library. Yeah.
One more question. JavaScript bind also has partial.
Yes, so JavaScript bind, call and apply will all do that. The only thing that Lodash does slightly better is that it will add metadata so that if you're like crazy partially applying and currying and memoizing things, it will make sure there's only one wrapper function, but you're also taking like a giant bundle, which is Lodash, which is like 24K, and to do that, so it depends on how much you're using Lodash, whether or not you should, if you have a small application, just use bind.
Right, but bind does like two things: binds context as well as partially applies.
Yes, I don't think Lodash does anything with context, so
It's
yeah.
weird. Why?
I mean, you can always import one function from Lodash into React.
Yes, so you can do that, and Lodash supports modules. The one thing that I would put as kind of like a caveat to that to be careful about is Lodash reuses way too much code. So the first function is like 5K, and then every function on top of that is bytes. So it's just kind of something to be aware of. Like I would recommend against using one function from Lodash. I did a project at Dropbox where we built a custom Lodash bundle so we could have a minimum bundle size, and we realized very quickly that eliminating single functions did not improve bundle size. You had to eliminate classes of functions. So that's a very good point. It's just there's the little caveat to be aware of. Sweet. So I have one more funny slide. So code written in Haskell is guaranteed to have no side effects because no one will ever run it. And it's a language built on latency evaluation, but nobody's actually called for it. Thank you so much. I'm Matthew Gerstman. Please follow me on Twitter. It's going to make me feel good about myself. So just do it and make me happy.